Good morning.
Good morning, sir. Bharat from NPTL.
Yeah, good morning. So we'll wait
Yes, sir.
for the students to come. Hello, I see some students have joined. Amit Tiwari.
Yes, sir. Good morning.
Yeah, good morning. Do you have any question?
No, sir.
Okay. Avinash,
No question, sir.
thank you.
Yes.
Sir, there is one question in chat box.
Yes, Avinash, this slicing AI-driven process, you know that it is possible only when artificial intelligence machine learning essentially is a data-driven process. So if you want to design a specific structure and that structure or similar structures, you have the prior experience in slicing and corresponding data available, then you can utilize AI to make it much more precise by using some of the machine learning algorithms to see how the preciseness and defining the actual structural aspects is possible. So, but one should have the corresponding data should be available, and then you can split it into the training data set, testing data sets, and then use the ML algorithm trying to see that how best you can do that, or you can optimize the parameters. Is it okay? Do you
Thanks
have
for
any
the
other
information,
questions?
sir.
Yes. Okay.
Okay.
Any other person? So everybody knows that this session is opens at 10:30, right? Hello.
Yes, sir.
Yes,
So
sir.
Yes, sir.
everybody knows that session is at 10:30, right?
Yes, sir.
Yes, sir. Everybody knows, sir.
What is the latest entry that a student can? Is it 10:45, 10:50, 11 o'clock, or what is the latest entry?
Actually,
in the
they
middle,
can join at any time, sir.
Oh, okay. So more than 11 o'clock, they cannot enter, right? This meeting.
They can join, sir.
After 11 also.
Yes, sir.
How long is this session? 1 hour, right?
1 hour, yes, sir.
Okay, thank you. Yeah.
Sir, there is one more question.
Hmm? Hmm? কেমন জানো? Hmm. পাসপোর্ট তাই তো? ঠিক আছে, তারপরে এটা কি বলো, টু বি ভেটেড বাই এফও নাকি?
You are not audible, sir. Your voice is breaking.
Hello, am I audible?
Yes, sir.
Is there any other question?
Yes, sir. Actually, there are two questions, sir. One from Ravina.
Yeah, just 1 second. I'm answering one by one. Is additive manufacturing technique like FDM limited to prototyping or can be used in manufacturing? Yeah, FDM, so far as I have seen, most of the industries they use for the manufacturing of the prototypes. Now, real electronics field application, it is possible only if the that electronics industries, what is the acceptability of the electronics industries, I'm not sure. So unless they accept that FDM because as a tool for their 3D printing of the components, I'm not sure whether it will be acceptable, because electronics, that's one of the major things, is the safety of the electronics components. And if the safety aspect is not compromised in the additive manufactured components, then it can be used. Do you have any other question, Ravina?
No, sir. Thank you, sir.
Am I audible now?
Yes, sir.
Then biomass. Hello, good morning. How feasible additive manufacturing methods over conventional ones? I think that it has been mentioned in my lecture that whenever there is a demand for customized components, customized parts, and components or parts with complex geometry and topology and complex architecture, then you cannot use conventional manufacturing, because conventional manufacturing will add to significant cost. And conventional manufacturing means, let's take the example of the metals. So metallic components, you can do machining to get the preciseness. But 3D printing, you can start with the raw materials as powders and then do all these SLM technique or DED techniques, and then you can feed the design of the corresponding component that you want to 3D print, and then you can do that. So therefore, where conventional manufacturing fails, additive manufacturing is the only option. So there is something called customized prototype, customized component developments, and then also in a limited volume. If it is a large scale mass manufacturing of the simple shaped components, then conventional manufacturing is a much better cost effective options. I hope it answers, Payamesh, or you have any other question?
Yes, sir. No, sir. Thank you.
Then Vijay, what is the current state of metals as the additive manufacturing? Metals, perhaps metals has the greatest future in the field of additive manufacturing, because if you see, not only for component manufacturing, but also for the repair of the components, these metallic components can be metal 3D printing methods are used, whether SLM, whether DED, whether lens, all these techniques, they have been extremely found to be useful, not only in the laboratory scale, but also the industrial scale productions. And there are companies who are innovating LPBF machines, that laser powder-based fusion machines, to increase the productivity or to increase the bed size, so that large number of components or more components with the smaller but intricate structures can be printed. That is people are investing a lot of time and efforts, as well as industries are very much interested on metal 3D printing. Yes, it's a great future. Any other question, Vijay? No. Anybody else has any other question so far? I'll call the name of the students. Amit has asked questions, or I asked Amit that whether Avinash has asked question. Kiran Kumar, do you have any question? That's
No, sir. No, sir.
Mandakini Vasant.
No, sir.
Ravina has asked. Taposh. Vaishak. Yes, no. Okay. So we'll wait for another 15-20 minutes in case some more questions pops up. Okay, is the human body part made by 3D printing, it behaves like original, or whether we can use cellular materials? Very good question. This is the question from Amit Tiwari. Now, human body parts, for example, if you consider the total hip joint replacements in the acetabular liner, like where the femoral stem, femoral ball head, as well as acetabular liner, the outer cover of the acetabular liner head, that is currently being manufactured by 3D printing, because that outer part of the acetabular liner, it will have a lattice structures. And these lattice structures are very useful. And there are industries in India, implant manufacturers, who have done limited clinical studies, and they are putting into the human patients. Spinal cages implants with cellular structure or lattice structures, that is also another thing that industry is exploring. Now, the question is whether it will behave like a original part. And for that, you have to do this clinical study for longer time period. But initial results show promising outcome. I can say at this point of time. Okay.
Okay, sir. Thank you.
Can you name few metals for future AM? Vijay is asking. Magnesium alloys, zinc-based alloys. These are copper-based alloys. Copper-based alloys they are using for 3D printing related applications. But cobalt chrome, this is also another materials that people have to do. So these are like different metals which people should explore more and more in the metal additive manufacturing area. Any question? So next question from Ravina, ceramics are more brittle. So can ultimately help in that case for complex part fabrication and which technique is best for ceramics printing? See, ceramics is difficult as you perceive that, they are very brittle in nature, but there is ways that, you can either focus from top down, laser beam, and there ceramics are mixed. We mixed with other material, then you make a slurry kind of things, and then you print it in a layer by layer manner, or there is a from bottom. So from the bottom, you can focus the laser as ceramics are kind of printing. Okay. So these are the two approaches that you can do.
Okay, sir.
Very nice to see so many questions that you are coming. Sir, in this course, we get to see and learn about metal powder 3D printing, IT manufacturing, or multi-metal printing in one print. So I think you will see more metal powder 3D printing, not multi-metal. Multi-metal printing is still in its infancy. Many industries have not yet adopted. Thus, are you able to listen to my answer? Uh, for polymeric ceramic nanocomposites, I think you will be seeing in the later part of the course, perhaps I have given some lectures. So polymeric ceramic nanocomposites essentially means ceramic are nanoparticles. Ceramics are very fine particles, nano-sized, and they are being dispersed in a polymeric matrix. And these polymer nanocomposites, you want to print it. So since the ceramics are loaded in a certain amount, these polymer ceramic nanocomposites can be 3D printed using a technique which is most suitable for that particular polymer. So any general response to such questions is difficult to give because it all depends on what kind of polymer you are talking about. So polymers, there are also thermoplastic polymers, thermosetting polymers, elastomers, and so on. So it all depends on what kind of polymers, what are their, um, shear thinning profile, and what are their viscosity, what are their thermoresponsive properties. Those kind of things are important. Is it okay, Mandakini? Do you understand my answer?
Yes, sir. Yes, sir. Thank you.
Vaumes has asked us, sir, how are desired microsurgery metallic metals achieved and controlled throughout the IT manufacturing, considering the rapid surgery and thermal gradient post-processing? Very good question. So essentially, if you see that laser material interaction, it takes place very fast. So it is possible to have non-equilibrium microstructure in these 3D printed materials. However, when you do heat treatment as a post-processing step, post-processing technique, then this microstructure also changes depending on what is the temperature of the heat treatment and so on. Thermal residual stresses are released. So that develops typically due to the thermal gradients and rapid heating and cooling during the laser-based processing. So this desired microstructure also depends from the strength perspective, hardness perspective from metals. Typically, finer the grain size, better is the strength properties according to the Hall-Page relationship, where strength of a polycrystalline materials is equal to strength of single crystals plus k d to the power minus 1 by 2. That means k upon square root d, where d is the average grain size. So finer grain size materials is always preferred in case of metals. Vaumes, you understand?
Yes, sir.
Any other? Very good question, Ravina. What are the job opportunities AM field in India? See, there are two ways I can explain to you. One is that who are the machine manufacturers in the field of additive manufacturing? Now, there are few companies in Bangalore. They are machine manufacturers or additive manufacturing. That is one scope of the job opportunity. Another scope of the job opportunity is that industries where additive manufacturing is used in their manufacturing line. There are also few medical implant manufacturers I know who they started using the additive manufacturing in their manufacturing line to produce components. So as that particular opportunity grows, like more and more additive manufacturing are being utilized in the industries for component manufacturing, there is the second job opportunity. Third, so initially I said two, now I'm saying three. Third job opportunity is that some of the companies like GE, they use DED technique or other IT manufacturing technique for the repair of their jobs, repair of the components. They are not necessarily manufacturing large components using additive manufacturing, but they use additive manufacturing for the repair of the jobs. So that is the third job opportunity. I hope I have answered your question, Ravina.
Yes, sir. Yes, sir. Thank you.
Sir, is AM used in component? Dax is asking, AM is component prototyping also? Yes, indeed, AM is also used in component prototyping. How is corrosion controlled during the IT match for iron-based alloys? Corrosion cannot be controlled. It all depends on the composition of the alloy. And corrosion, as you know, by definition, it is a electrochemical reactions which leads to damage or material removal of during a process. So therefore, iron-based metals, depending on what is the alloying elements, and then also what is the local electrochemical cells development in an aqueous environment or in an exposed to very aggressive environment, corrosion depends on those aspects also. We cannot predict the corrosion of alloys just because, or we cannot comment just because of additive manufacturing that corrosion is compromised or corrosion rate is increased tremendous. But at the same time, you must be aware of the fact that additive manufacturing components, they also have certain amount of porosity. So this porosity also leads to the infiltration of the different reactive liquids into the components, and that may cause also local corrosion. I hope it answers your question, Ramesh.
Yes.
Okay. Sir, can noble gases be used to prevent corrosion or not? I don't know. I did not understand this question. What is the meaning of noble gases in corrosion? It all depends on the application environment, right? So application environment, you cannot ensure that they will be only surrounded by noble gases. And it's very unlikely. Okay, I hope this session is useful to everybody.
Yes.
Yes, sir.
Is there any other question? We are coming to the end of this session. That's why I'm asking. Shall we end the session now?
Yes, sir.
Anybody else has any other question? Last chance. Okay, thank you very much, everybody.
Thank you, sir.
Thank you, sir.
Thank you.